In order to calculate standard enthalpy change, you have to use values in Appendix C, and you use the first value that they give you. And so I looked up what SO2 is, as well as O2 and SO3, and the value that they give you is per mole, or per one molecule of it. So for the SO2, I had to multiply by 2, and O2, any pure substance, any pure element found in its natural state is 0, and then SO3 will have to be multiplied by 2 as well. So that gave me negative 593.8 for SO2 and O2 for reactants, and then negative 790.4 for products. And to find out the enthalpy, you have to do products minus reactants. So I did negative 790.4 minus negative 593.8, and I got 196.6. You repeat the same process for the next one. You have MgOH, and that's a solid, and then you have MgO solid, H2O liquid. And for this, you have negative 924.7. That's the enthalpy for MgOH2. And then for MgO, it's negative 601.8. And then for H2O, it's negative 285.83. And so I have negative 924.7 minus, and then I have negative 601.8, and then I just didn't write it, I just drew an arrow. Negative plus negative 285.83. Now for this one, I decided to do negative reactants plus products, because if you distribute the negative, you're going to get a positive number over here, and it's going to be bigger than the reactants. So I just decided to keep it this way instead of rearranging the equation, and I just put negative reactants plus products, which gives me 37.1, or 37.07. Now, you do the same process again. CH4 gas is negative 74.8. Cl2, it's found in its element, its natural state is a gas, so it's 0. So 4 times 0 is 0. And then CCl4 is in the liquid state, which is negative 193.3, plus 4 times HCl, which is negative 92.3. And that you get negative 74.8 plus 475.9, and I just decided to keep it again as negative reactants plus products instead of doing products minus reactants, and I get 433.7. And for the last one, there's CiCl4 in the liquid state, which is negative 640.1. H2O, for the one molecule of H2O is negative 285.83, so I had to multiply by 2. And then minus SiO2, which is 910.9 plus 4 times 1 molecule of HCl, which is negative 92.3. And that gets me, over here is 1280.1, and then on the reactant side it's 1211.76. So I decided to flip it this time, and I did 1280.1 minus 1211.76, and I got negative 68.34.